Here we go. All right. So what's the derivative of e to the x? I said, what's the derivative?
Oh, e to the x.
E to the x. Therefore, the integral of e to the x is e to the x plus c. All right. What's the integral of e to the u?
U times U prime. U prime.
No, it's e to the u plus c. It's to the du.
Oh, that's true. Oh, my bad.
Okay. Your goal when you're doing these integrals is essentially to make it look like this. Everything's going to be a u sub. All right. And when you get it to the point of e to the u du, it's e to the u plus c. You plug back in what your u is. Okay. Every question is basically a u sub question with e's. So let's start with the examples. What do we want to do? E to the 3x plus 1 dx. All right. Whoa. Unless you have just an x as the exponent, you have to do u sub. Okay? So what is u going to be? 3x plus 1. So du cx. So then you get the integral e to the u du over 3. You can pull the 1/3 out. You don't have to, but if you want to. And then what's the integral of e to the u? So we just have, remember the 1/3, e to the u plus c, put in what u was. That's it. This is what we're going to do every time. All right? And most of the stuff is rigged. This is first year calculus, high school calculus. So it's all rigged to work. So let's do, what was that? 1, 2. What? 8 to 2. Perfect. E to the 1 over x squared. What's the only thing you can be here? Yeah. If you have an e in your integral, 99% of the time, if it's just one e, you're going to do a u sub of that exponent. If you have multiple e's, then it can be a little different, but most of the time it'll be just that exponent. Yep. You mean x to the negative 1? It would. You mean like write it like this? Like that? But that's not the same. Yeah. That's okay. So it's 1 over x, which is x to the negative 1, which is what you were getting at. So the derivative of that is negative x to the negative 2 dx. What am I going to do? Does this help us? Yes. Because x to the negative 2 is 1 over x squared. The negative I'm going to move to the other side, so negative du. But this is 1 over x squared dx, which is that. So our integral becomes integral e to the u negative du. Essentially, you can pull the negative out. That's it. All right. Let's do some. Oh, let's do a trig one. Everybody loves trig. And then we'll do a couple definites. Okay. What are we on? 3? Z? D? Okay. What do you mean, how did I get a negative? Like, do you understand this bit? Please? So I drop the exponent down.
Oh, because the exponent's negative.
We're good?
Yeah.
All right. All right. D. Integral. We'll make it straightforward. Sine of x e to the cos x dx. I don't know. Are we doing letters?
I mean, you did A to and now we're whichever you want.
We'll do Roman numerals next. So what's u going to be? Cos x going to be the exponent. Negative sine x dx. You got to move the negative over. And then it is negative e to the cos x plus c. Yeah? So these look weird at first, but they're actually pretty straightforward. When you have a single e in there, it's almost like this is just what you do. Sub out the exponent. After that, it's pretty straightforward. It's just a basic u sub. All right. What if you don't? What are we on? 4. Integral from 0 to 1 of e to the x over 1 plus e to the x. Uh-oh. So first of all, definite integral. So we're going to get a number. And we have multiple e's. If you have multiple e's, you're not going to sub out the exponent. What am I going to sub out? The denominator. So it's either going to be the numerator or the denominator. So we'll just try the denominator because that's usually what we go with. What's the derivative of 1 plus e to the x? Yeah, it's just e to the x, right? Look at that. It's magic. Which is our numerator. Okay, do we want to change variables? I think we should change variables. Right? Because we're changing, like this integral is going to become this. Integral of that's du and that's u. 1 over u du, right? So now we've written the integral in terms of u's, not x's. This 0 and this 1 are x values. So I want to sub out them. So we go when x is equal to 1. When x is equal to 1, what does u equal? 1 plus e. Oh, hang on. No, e to the 1 is e. For the second one, it'll be 2, yeah. All right. And when x is 0, E to the 0 is 1. 1 plus 1 is? So we go from 2 to 1 plus e. Nice bounds. What's the integral, or what's the antiderivative of 1 over u? Ooh. What we did on Friday, I think. It's the natural log of u, and we're evaluating it from 2 to 1 plus e. The antiderivative of 1 over u is the natural log of u. Remember, we did that on Friday. Nobody seems to remember that.
It was a Friday.
It was Friday, so it doesn't count?
Yeah.
Okay. Then we plug in our upper bound. I guess I don't need absolute values because those are going to be positive. And the lower bounds. And then you're going to punch it in your calculator and tell me the answer. I don't know what the answer is to this. Maybe I should do it.
How do you even do it? Oh, there's it. But it's absolute.
You don't have to put the absolute value in.
I got syntax error. I'm just waiting for an answer.
0.62.
Whoa.
See if you can get that.
How do you get that? What's E?
You should have an E button on your calculator. To the power of 1.
Oh, to the power of 1, that's what I did.
Yeah. Did we get it? I mean, look, you can just leave it as on a test. You can leave it as natural log of 1 plus e minus natural log of 2. That's the more accurate answer anyway. I just want you to be able to do it on your calculator as well. I'll help you decide. Let me do a couple other ones. All right. Can we do another one? May we do another one? Happy face. Okay, what do you want to do? U is going to be cos EX? I would go with e to the x. Because if you make u cos EX, the derivative is going to involve a sign, right? And we don't have a sign. So we're just going to go u is equal to e to the x. So du is equal to e to the x dx, which works out nicely because it's that bit right there. Yeah, so we'll change the bounds. I'm going to write the integral first. So I'm going to get the integral of cos u du. But we got to do the bounds. So when x equals 0, what does u equal? 1. When x is equal to negative 1, u is equal to? One over e, right? E to the negative 1. Because you just put a negative 1 in for the exponent. Does that make sense? So it's 1 over e. Okay, what's the antiderivative of cosine? Sine of u from 1 over e to 1 is going to be sine of 1 minus sine of 1 over e. Just for the fun of it, let's put it in our calculator. Because What mode do you have to be in? Rads. Those are not degrees, people. Those are radians. On a test, you can leave it like that, but I think we should just practice because at some point, you'll probably be asked to do this. Unless you're in Avery's Math 100, in which case you get no calculators. So 0.48. Syntax error is not an answer.
I got 0.74.
You got it.
How are you doing this?
Or you just do step by step. Write them down. Because if you mess up the brackets, then it all goes sideways.
Like e to the power of 1, not just e1. Well, it's automatically just e to the power of 1. Huh? What are you cooking? This stuff? Oh, yes. Oh, I was cooking today. I was cooking this. Oh, yeah, that's why it's not working. Yeah, I got 0.48. That's I'm still getting confused. I don't want to do this. I don't know how to do
I'll help you at the end. I'll help you after. It's the last question.
Oh, okay. Oh, we're sad because it's ended.
Yeah. Well, it's not like the last question of the course, but it's the last mini question. No, I don't even want to say for today. I'm not sure yet. All right. What do we do?
Simplify. Put it divide everything by e.
Yes. If you have a single denominator, break it up. Yeah, because you can write them as separate integrals if you want. And I forgot all the dx's, but assume that the dx's are there. I just forgot to write them. Does everybody understand that move? Okay, what should we do now? Simplify them. So if you're dividing with the same base, what do you do with the exponents? Subtract them. So 2x minus x is, second one just becomes 2. And the third one will flip up and make it e to the negative x. And I forgot the dx's again. I'm going to write them in. dx. dx, there we go. All right, the first two we can do, those are pretty straightforward, I think. What's the integral of e to the x? We can save that till the end. What's the integral of 2? And then we have to deal with this one. But we've already done it. It's negative e to the negative x. We did it up here.
Can you explain how that works? I didn't understand.
So if we go up here, did we not do it? I did. Okay, well, let's do it. Okay, so you're going to go u is equal to negative x. So the derivative of that is negative dx. Yeah? Move the negative over. Negative du is equal to dx. So this integral then becomes the integral e to the u, and it's negative du. So I'm going to put the negative there and that there. What's the integral of e to the u? E to the u. So this becomes negative e to the u, and u is negative x, negative e to the negative x. So that's what goes in right at the last spot. Or I guess it would be minus e to the negative x. And then what should we do at the end? Because it's indefinite. Throw a plus c on, and you are done. And you just wait to the end to do the plus C, because yes, each one of these would be like plus C, plus C, plus C. But what is constant plus constant plus constant? Constant. So we just put a plus C at the end. Is that okay?
Is it possible to use
Is it what? Sorry? Do you mean the original?
Yeah.
Yeah, well, that wouldn't work out. All right. Page 354. Numbers 91 to 117, please. And then I'm going to decide if we need to do more.